So good day everyone, I'm here to solve another challenge from Sir Lagos. So the we have here is the find the area of the curve. So first we only have a given here, which is y1 equals to x squared, then y squared is equal y2 is equals to the square root of x. So we don't know which will there intersect. So first we need to find the intersection points. So we go here, y1 is equals to y2, x squared is equals to square root of x. X squared is let's transfer square root of x here to x squared, so it becomes negative square root of x equals to 0. So what we do here is to square each of them. So x squared minus square root of x plus 0 squared. So what happened here is we distribute the squared here to each term. So x raised to the 4th minus square root and 2 will cancel out. What will be left is only x equals to 0. Then we factor this equation to x equals to x cubed minus 1 equals to 0. Then we clear x, then we factor 2. Then we also factor this equation, x and x minus 1. We factor this, x squared plus x plus 1 equals to 0. So x equals to 0, x minus 1 equals to 0 equals to 1. X squared plus x plus 1 plus x plus 1 equals to 0. So our x here is x equals to 0, then x is equals to 1. So if we first we equate this when x and y, when y is equals to 0, then here we substitute 0. 0 squared is 0 plus 0 is equals to 0 plus 1, and our x is 1. When x is 1, 1 squared is 1 plus x is 1 plus 1 is 3. So I don't think so that is all. Then we have here our x equals to 0, then x equals to 1. So we go here to substitute them to illustrate them. So the point here is 1, x equals to 0, then x equals to 1. This is 1. Then 1, y is 1 also, is y. So the point of intersection is 1 1 and 0 1. And then we shade here. Then we put the vertical strip here, then we put it outside. Let's say here, vertical strip. So our vertical strip is y squared minus y1 dx. dA, or we differential area is equals to y squared minus y1, then the area is equals to the integral of y squared y2 minus y1 with limits from 0 to 1. 0, is it clear? 0 to 1. So we solve this equation. So a is equals to integral of x 1/2 minus x squared dx from limits to 0 to 1. So we integrate this part, which is easy because x raised to 1/2, we just use the power rule to solve this, equals to integral of x plus 1/2 plus 1/2 is 3/2. So 3/2, and by its denominator we reciprocal that, so it becomes 2/3 x 1/2 3/2 I mean, minus x squared, we just use the power rule here. X squared plus 1 is just x raised to the 3, x cubed over 3 with limits from 1 to 0. So now we solve them. So we substitute each of them the limits, the x, and 2/3, we replace x to 1 raised to 3/2 minus, we replace the x to 1 1/3 1 raised to 3 over 3 minus the lower limit, which is we know is 0, so we put 0 here. And by finalizing this, 1 2 2/3 and 1 raised to 3/2 is just 2/3 1. So let me get my calculator first. So now we have a calculator here. So we solve this. It's blurry. So now we have a calculator here that solve this problem, and by inputting it to the calculator. Wait. So 2/3 times 1 raised to 3/2 minus 1 raised 1/3 raised to 3. So the answer is 1/3. So 2/3, the answer is 2/3 minus 1/3 is just 1/3 square units. So that's all for this video. Thank you for listening.